It's a typical winter morning. It snowed some last night, and the morning thaw has left the ground muddy. It's a pretty average trench, like hundreds of others you've been in. It's shallow, only 4 or 5 feet deep. So what's there to worry about? But look a little closer. Are there any danger signs? Is there water seeping in? Is heavy equipment parked too close to the edge? Is there a ladder or other means of exit in place? Is dirt stored too close to the sides where it could fall in? Maybe these little things don't seem important. This trench is not very deep. It's not very long. But when you think about it, the crew that excavated it moved tons of earth. Think about those thousands of pounds of cold dirt. Because if you're not careful, if you enter an unsafe trench or excavation, it could bury you alive. Know when to enter. Know when to leave. It may save your life. Every year, at least 100 workers lose their lives in construction-related trench cave-ins, and more than 1,100 suffer disabling injuries. NYNEX wants to be sure that all of our field technicians are protected from this type of danger. Hi, I'm Tony Cucci, and I'll be your guide for this safety awareness module. Some of your coworkers will also pitch in as we cover all the basics of safety in trenching and excavating.
Morning, Michelle.
Hi, Kay. How you doing?
Since the early 1970s, OSHA has set standards related to this type of work. By the early 1990s, the increase in accidents due to cave-ins was so serious that OSHA added their first major revisions in 20 years. OSHA has characterized excavation safety as a special emphasis program. This video is part of NYNEX's response to OSHA's program, and if you work in or around excavation sites, it's vital that you see it. It's important for all of you to know when to stay out of a trench and when to get out if conditions change. To do this, you need to learn how to recognize potential hazards and substandard support systems. This is a safety awareness lesson, not a course in how to dig a trench. In this safety awareness module, we'll cover what OSHA describes as general precautions or how to recognize hazards related to trenching and excavating. We'll also learn about soil classification, acceptable and unacceptable ways to protect trenches, and OSHA's definition of the competent person. While it's good to know that someone else is looking out for you, it's a smart idea to learn trenching and excavating safety basics so that you can determine the safety of a work site and the appropriateness of the protective systems. It may be someone else's job to protect you, but it's your right to know how they're doing it. So next time you arrive at an excavation work site, whether or not the competent person is there, check it out for yourself. And remember, just because it looks safe doesn't mean that it is. We asked Kay Coffey, a compliance officer and construction specialist with OSHA, to tell us what he looks for when he inspects a job site.
We're looking for the condition of the excavation, the depth of the excavation, whether or not the spoil bank is stored too close to the face of the excavation. We're also looking for things like water hazards, water that might be in the trench, or equipment working too close to a power line, or things of that nature.
One of the most important factors affecting the stability of your trench is the quality and condition of the soil. To provide optimal protection, NYNEX treats all soils in their territory as the poorest and least stable. Still, it's a good idea to have a basic working knowledge of soil types and the OSHA classification system. Just to make sure that you have the best information, we went to an expert, Professor Jim Mellett from the Department of Geology at New York University.
To simplify things, we're going to look at the difference between soil and rock with a very simple test. If you can dig into it with a shovel or a backhoe, it's a soil. If you can't dig into it, it's solid rock. But you have to be careful even in an excavation in solid rock. If you have layered rock and it's horizontal, it will be stable. But you occasionally run into cases where the rocks are tilted, and if they slope into an excavation, they can collapse with disastrous results. Now, soils are composed of 3 different materials: gravel, sand, and silt and clay. Now, it's the mix of these materials that determines the stability of the soil. If it's very rich in clay, it's a cohesive, solid soil. If it's higher in sand and gravel, it tends to be weaker. OSHA classifies soils into 3 types on the basis of their strength. The type A soil is the strongest and the most cohesive. This has a great deal of clay into it, and a simple field test allows you to roll it into a rope. Type B soil has less clay in it. If we try that same test with a type B soil and try rolling it, you can see it crumbles. Type C soil has almost no cohesion and will fall apart.
The soil found in NYNEX territory varies as widely as it would in any terrain that includes Rocky Mountain ridges and sandy beaches. Although OSHA provides tests to determine soil classifications, in NYNEX territory, all soil is regarded as Class C, the poorest and least stable. NYNEX has several reasons for this. First of all, almost all of our soil has been excavated at some time in the past, and we usually uncover buried cable or conduit. It also eliminates the need for NYNEX personnel to attempt to define soil type. It eliminates all the tests that determine soil type. It makes contractors more accountable for protecting the excavation properly. Finally, and most importantly, it allows us to provide maximum protection for our technicians. The stability of the soil is key to the stability of the excavation. Here are some of the most common factors that you should be aware of. An increase or decrease in natural water content will weaken most soils. Rain, snow, and water line breaks can flood a trench. Water must be removed by pump, but if it's removed too quickly, the excavation can become unstable. For this reason, the competent person must be extra cautious with inspections and pumping supervision after rainstorms.
Water cuts 2 ways in an excavation. If you have dry material, it's not coherent, it doesn't stay together, it falls apart. On the other hand, beyond a certain point, the addition of more water makes the sand saturated, and a saturated sand is extremely dangerous and subject to collapse. Now we have just enough water to make it moist, and the soil is coherent. We'll get a vertical trench. As we introduce water into the system, it displaces the air in the sediment, and it saturates it. Now you don't have a coherent soil anymore. Now the particles begin to flow, the trench collapses, everyone inside the trench is also trapped. Now, where does the water come from? A heavy rainstorm nearby, a leaky or a broken water main or a sewer main, water coming in from a nearby excavation, and you suddenly have a disastrous situation develops very quickly, so quickly in fact that you will not be able to respond. It will happen that fast.
Besides water, other factors that affect soil stability include drying, previously disturbed soil, vibrations from heavy equipment or traffic, and surface loads from spoil piles or equipment stored too closely to the edge of the trench.
All right, let's look at some of the physical principles involved in trench excavation and in trench collapse. If we look at a pebble underground, we can see that the forces on that pebble are all equal, the vertical and horizontal forces. If they weren't equal, the pebble would move. However, if you start excavating and trenching and removing material from it, you introduce an unbalance. And you'll see what happens. We trench down to here, and these lateral forces that were opposing one another now have open space between them. So you have unrestrained or unresisted forces pushing in on the trench. As you excavate, they go down 4 feet, go down even more. The deeper you go, the more of these lateral forces you introduce until you can reach a point where the entire system will become unstable and will fail.
OSHA assigns the title Competent Person to an individual who has been specially trained to identify any existing or potential hazards at an excavation worksite. This individual also has the authorization to immediately stop work and correct the hazard.
Hi, I'm Steve Bryant from Keene, New Hampshire Contract Work Inspector. I'm here to fill you in on what to expect from a competent person. The competent person makes daily inspections before the start of the workday, and again as needed throughout the shift. He or she also inspects after every rainstorm, thaw, or any other situation that might change the stability of the excavation. The competent person should inspect the excavation, the surrounding areas, and the protective systems. He or she should look for evidence of cave-ins, faulty protective systems, hazardous atmospheres, and any other dangerous conditions. If a hazardous situation of any kind is discovered, all technicians should leave the excavation area immediately until precautions have been taken.
The competent person's job is to protect you, but the decision to enter or leave the excavation is ultimately yours.
Quite a few years ago when I was working on a site, I was witness to a terrible, terrible cave-in, and that was the lack of proper sheeting. They were using a lot of plywood. The scariest thing I ever seen. I heard a loud thunder, everything came on top of us, and I just watched them go, buried alive. It was the worst nightmare in this business. I get the chills now. I get the chills just thinking about it. And that's why I do my daily routines every day. Safety's first. A man's life is more important than anything else.
So we want you to treat every excavation with great care. When you get into it, keep in mind that you're entering the jaws of a trap that could snap shut at any moment. If you see fissuring at the edge of an excavation, warn the people in the trench and get out. If you see the internal walls of the trench beginning to bulge in, collapse is imminent, get out. If you see water seeping into the floor of the trench, get out as quickly as possible.
Your job is to repair the plant. Your responsibility is to go home uninjured. We're going to take a break now. When we come back, we'll show you what general precautions to take, and we'll give you a good overview of the most common protective systems you can expect to see in trenches. See you in a few.
OSHA is here, the city engineer is here, the fire department, the police department, and they're all working on it right now.
We're reporting live from Northwest Yonkers, New York. What we're showing you now is a high-angle shot of a 15-foot deep trench that has tragically become the grave for a construction worker who was working on a sewer main here. He died despite the heroic efforts of a team of emergency workers from as far away as New York City. Authorities won't let us get any closer at this point.
People die in trenches. It happens too often, sometimes right in our own backyard. This time it was a construction worker working on a water main. Don't let it ever be you.
What happens is a combination of things. The sand and the soil compresses your legs. The legs don't get any blood flow, and your legs literally begin to die. If you had a boulder roll up against your legs while you were in an excavation and suffered tissue damage, in that case, you would be fine as long as the pressure was on you from the surrounding soil. However, as soon as you were brought out of that excavation, that damaged tissue would be pumped to the rest of your body. This is known as a toxic crush syndrome. Death is almost certain as a result of this.
Before any work at an excavation site begins, the contractor and the competent person should have inspected the site for hazardous conditions. You should look for these hazards as well, to be aware of potential danger and to familiarize yourself with whatever precautionary measures have been taken. Here are some of your co-workers to walk us through the hazards common to excavation work sites.
Hi, I'm Richard Vaughan out of Greenville, Long Island. and I've been with NYNEX since 1971, and I spent a lot of that time in excavations. It's a good idea to look for surface obstructions as soon as you get to the work site, especially if it's located in a developed area or near roadways or utility structures. Make sure that anything that has been undermined is well supported. That includes light poles, telephone poles, trees, curbs, hydrants, or anything else that could have been affected by the excavation. You should also look for other underground utilities such as electric, sewer, fuel, water, and gas. Make sure that a temporary support has been provided if necessary. Underground service is usually exposed by machine excavating, then by hand digging to reach the pipe. I don't have to tell you that breaks in water, gas, and electric services can cause serious or fatal injuries. After cave-ins, breaks are the second leading cause of death in underground installations. Breaking a gas line can cause an explosion, and hitting an electric line can cause electrocution. Always be sure to know the location of all utility lines while you're working.
I'm David Collins from Concord, New Hampshire. I'm an outside plant technician, and I'm here to talk about trench access and other safety factors. If the trench is more than 4 feet deep, we need to use a secured ladder, stairway, or ramp to get in and out of it. The ladder has to be located so that we never have to walk more than 25 feet in the trench to reach it. Ladders have to be extended 3 feet above the top of the trench, and they need to be anchored securely at the top and the bottom.
If you're exposed to traffic, you want to make sure that you'll be seen. Whether you're in or out of the trench, always wear a warning vest. And speaking of personal protective equipment, don't forget that it's NYNEX company policy to always wear your hard hat, safety glasses, and gloves in and around the trench.
Never stand under digging or lifting equipment, and stay away from trucks when they're being filled. If you're the vehicle operator, the safest place for you is in the vehicle. Vehicles loading dirt or unloading pipe shouldn't be parked too close to the edge of the trench. They might fall in or cause the side of the trench to collapse. Use hand signals or barricades to notify operators of the vehicle's position. Stop logs or timbers should be used to stabilize the vehicle.
Hi, I'm Mike Haug, construction equipment operator from Empire City Subway, and I've been working in the trenches for 14 years. I learned that if you're working near a dump site, a landfill, a gas station, or where a gas main has been damaged or exposed, you have to be aware the atmosphere might change to a hazardous condition. If you suspect that your trench may have a hazardous atmosphere, get out and notify the competent person. He or she will call the proper agency or emergency number. Sometimes a trench is located in an area with a lot of pedestrian traffic. If pedestrians or technicians need to cross over an excavation, the contractor should provide walkways or bridges with guardrails. NYNEX technicians are not usually expected to work in excavations with accumulated water. But if an emergency situation makes this necessary, the water should be removed to a controlled level and the flow watched very carefully. Before technicians can enter the trench, it has to be determined safe by a competent person. If you store heavy objects too close to the edge of the trench, it might cause loose rock or soil to fall in. Make sure that all spoil piles and equipment are kept at least 2 feet from the edge.
There are 3 basic protective systems: slope sides, shields placed between the sides of the trench and the work area, and shoring systems. Protective systems are mandated by OSHA for trenches over 5 feet deep. The competent person can select protective systems for all excavations under 20 feet. Systems for excavations over 20 feet have to be designed by professional engineers. Protective systems may not be required for excavations under 5 feet if there's no indication of potential cave-in. But remember, shallow trenches must be protected if there's water, vibrations, or loose or moving soil. These systems aren't necessary when the trench is in solid rock, but you won't find many of these in NYNEX territory.
Now, we have here a amount of dry sand. What I'm going to do is pour the sand into the aquarium with, and make 2 piles out of it. You'll notice as it pours, The angle that it makes remains the same. Regardless of how high I pile this, the angle will remain about 30 degrees. So we have one pile over there. I'll make a matching pile on this side. We pour until we have piles that are the same height. And again, you'll see that the angle is the same on the left-hand one as on the right. This is a stable excavation in type C soils. Now, to get a trench that is 10 feet deep, excavated without shoring, it has to be 30 feet wide. Now, although this is a safe excavation, it's totally impractical in the world that we live in. It doesn't work in city streets, it doesn't work next to railroad crossings, and it simply takes up too much space. That's the reason you will see shoring and protective systems in trenches that are made in NYNEX territory.
Hi, I'm John Morelli. I'm a backhoe operator with the Nassau Subsurface Group, and I've been digging trenches for NYNEX for about 8 years now. Trench shields are steel or aluminum boxes that sit in the trench. They provide a safe housing for technicians. Shields won't prevent cave-ins in the same way that sloping and shoring do, but they will protect workers from cave-ins. The shield should be installed to prevent side shift or lateral movement. Workers should remain inside the shield whenever they're inside the trench. They should never be inside the shield when it's being installed, removed, or moved vertically. The shield system is a fixed form of protection, and it's very limited in its application. It's not adjustable to varying conditions in the trench, and it's impractical when other utilities are present.
Shoring systems are designed to prevent cave-ins by supporting the sides of the trench. The two most common types of shoring systems that we can expect to see in our work are aluminum hydraulic and timber. Shoring is applied from the top down, and it should follow the excavation closely. The longer a trench goes unsupported, the greater the risk for a cave-in. Shoring should be removed from the bottom up and backfilled as soon as possible. Sheeting is the part of the system that bears directly against the trench wall, holding the earth in position. Sheeting is sometimes called uprights or piling, and is supported by other members of the system. Close sheeting refers to the placement of planks side by side, allowing as little space as possible. This type of sheeting is always seen in type C soil. Another term you may hear is tight sheeting. This refers to pieces of timber or steel that interlock. This is usually required in areas known to have high water levels.
What we're doing now, get those whalers over here.
Whales, sometimes called whalers or stringers, are the horizontal pieces running the length of the excavation against the sheeting. The horizontal spacing of the whalers is determined by the depth of the trench. Braces, or cross braces, are the horizontal pieces that run the width of the excavation and are fitted against the whalers. While you don't see it much in our type of work, you may go into a trench where the contractor has set up aluminum hydraulic shoring. This is a pre-engineered system which uses aluminum hydraulic cylinders as cross braces to hold the horizontal whalers, which in this type of system may be either wood or aluminum. Most NYNEX excavations are timber shored. The timber has to be strong, in good condition, without defects, and they have to be the right size. That means no 2x4s or plywood. Plywood should be used for cosmetic reasons only, for example as a clean floor surface. It does not meet the OSHA standards for shoring systems, and it will not protect you against cave-ins. OSHA provides tables with minimum requirements for timber shoring for the types of trenches that we work in. The tables list differently sized trenches and different timbers, as well as recommended spacing for the timber. NYNEX technicians are not responsible for the design and construction of shoring systems, but it's a good idea to understand how the OSHA tables work. Let's use the table for one example. Let's say we're using Douglas fir in type C soil. We need a trench 8 feet deep and 4 feet wide. The uprights must be at least 3x6 timber installed as close sheeting. The whalers, or stringers, must be a minimum of 10x10 with a 5-foot vertical spacing. Cross braces should be a minimum 6x6, also with 5-foot vertical spacing. 2x4s and plywood don't even show up on the chart and are not strong enough to protect you. Many tragic trenching and excavation accidents would not have happened if the right precautions had been taken. It's the responsibility of your employer to make sure that a competent person has inspected your excavation worksite. But don't let it go at that. Always check it out for yourself. You're the person in the trench. You're the one at risk. Learn how to identify hazardous conditions so that you can be sure to protect yourself and your family. Know when to enter, know when to leave.
So fast, so fast. These things happen so fast.
The park owner was digging for a water main leak in this area. In the process of digging the trench, they cut a 6-pair buried service wire. So we were called to come in and repair the wire.
The field tech told me later that he walked into the ditch. It looked perfectly okay to him to start with, but by the time he turned around to start to walk out, and the next thing he was stuck.
He tried to work his own way out, and each time he moved his legs, the mud was acting just like a suction and was pulling him down deeper and deeper.
We got him harnessed and tied off, and then we tried, slow but sure, and move the mud away till we could free him. You could only stay in that hole for probably 10-15 minutes shoveling, and if someone else had to go in, otherwise you were exhausted, just from the weight of the mud. He was in there for a good 3 hours.
What would appear to be a fairly safe, routine job in a pit of shallow dimensions could easily, and in this case did, turn into a very hazardous situation.
Everyone thinks it'll never happen to me. I know I've been there. And it's going to happen to you sooner or later.
We've had 2 fatalities in this local, and I'm just trying to make the members all throughout NYNEX to start thinking about safety as part of your work habits. You have to, otherwise we're going to have a lot more flags flying in this company, and that's something we don't want.